So you've probably played around with an AI coding assistant, right? It feels like magic when you're just spinning up a quick prototype. But then, you try to get it to do real work on a massive, existing codebase, and poof, it just falls apart. Well, today, we're going to get past that. We're moving beyond just basic prompting and diving into a real professional methodology for getting production-ready code out of these AI agents.
And let's kick things off with a reality check that I'm sure is going to hit home for a lot of you. There was this big study recently that basically just confirmed what we've all been feeling in our guts. For these complex, existing code bases, the brownfield projects, AI tools can actually make things worse. They can be totally counterproductive, creating way more problems than they actually solve.
Yep, this is what I like to call the AI coding wall. It's that point where the promise of lightning-fast coding just fizzles out and you're left with a mess that creates more work, not less.
So let's break down exactly what this wall is made of. We're talking about code that leads to a ton of rework. The AI just completely fails when it's thrown into a large, complex repo. It really struggles with legacy code bases. And honestly, it can even slow down experienced developers. The result is what a lot of us are starting to call slop. Code that looks okay at first glance but is full of holes and needs a ton of fixing. And because of that, these incredible tools get stuck doing simple prototypes, never getting close to production.
Okay, so how do we get past this wall? How do we break through? You might think the answer is just a smarter AI, right? A better model? Nope. The real answer is mastering one single core principle that runs everything: context.
This is the light bulb moment, right here. An LLM is basically a pure function. What does that mean? It means it has zero memory, no state. It's like a brand new machine every single time you talk to it. The quality of what comes out is 100% determined by the quality of what you put in, the context. It's the ultimate garbage in, garbage out system. So getting high-quality context isn't just about getting better code. It's literally the only way to get good code.
I love this slide because it shows you what's really happening. It's a battle for your context window. On one side, you've got the bad guys, the context polluters, things like bad info, missing files, or just pure noise, like pasting in a giant, messy debug log. And on the other side, you've got your heroes, the context optimizers, making sure everything is correct, complete, and concise. Your job, as the engineer, is to be the general in this battle. Wipe out the polluters and champion the optimizers.
So once you get this, everything changes. Your whole workflow can evolve. We can finally move away from just, shouting at the AI in frustration and start using a real, deliberate strategy.
Think of it like leveling up your skills. At level 1, you're in what's called the naive loop. You're just yelling back and forth with the agent until it gets confused, you run out of context, and you have to hit reset and start all over. Annoying, right? Then you hit level 2, intentional compaction. Now you're getting smarter. When you're about to run out of context, you purposefully summarize everything into a neat little file to get the next agent up to speed. But level 3, that's where it gets really pro. You start delegating. You offload the heavy lifting, like searching a whole codebase, to a sub-agent. That little guy does the work and reports back only what's critical, keeping your main agent's context clean and focused.
But even these levels can feel a bit chaotic, a bit ad hoc. What we really need is a professional methodology, a complete, repeatable workflow that's built from the ground up around managing context.
And here it is. The whole thing boils down to a simple 3-phase workflow: research, plan, and implement. Notice the order. We're not jumping straight to code anymore. First, you invest the time to really deeply understand the system. Then, you create a super detailed plan. And only after all that do you unleash the AI to implement that very specific plan. Now, if you remember one thing, make it this: the golden rule of this whole workflow. Always aim to keep your context window usage under 40%. Why? Because it gives the model elbow room, enough space to actually think and process without getting confused or bogged down. The less of that context budget you use, the better and cleaner your output is going to be. It's that simple. Okay, so what does this actually look like in practice? Let's talk about the research phase. This isn't just about you learning stuff. The most important thing that comes out of this phase is a real, tangible artifact, a simple file. And in that file, the exact file names and even the line numbers that are relevant to the task. You do the hard, expensive work of searching the codebase one time. And that's it. The agent never has to waste its precious context trying to find things.
And this requires a huge mindset shift. The plan becomes your new source of truth. So if the implementation starts going off the rails and you find yourself yelling at the AI again, stop. The problem isn't the AI. The problem is your plan. You need to stop debugging the code and start debugging your spec. That changes everything.
You know, the crazy thing is, the benefits here go way beyond just writing code faster. This workflow can fundamentally change how your entire team works together and where you find your leverage.
Just look at this. It says it all. What would you rather review on a Friday afternoon? A monster 20,000-line pull request full of AI-generated Go code? Or a clean 200-line implementation plan? The answer's obvious, right? By getting your team to review the plan before a single line of code is written, you catch those big architectural mistakes early. You get high alignment with low effort. It's a total game changer for collaboration.
And hey, this is not just some nice theory. These are actual, real-world results. Check this out. Fixing a bug in a 300,000-line Rust code base, the PR got merged directly by the CTO. How about adding WASM support to an entire language? That sounds like a multi-week, maybe multi-month project. Done. 35,000 lines of code shipped in 7 hours. Or how about this? A new intern shipping 10 production-ready PRs by day 8. This isn't for little toy projects. This workflow absolutely delivers on huge industrial-scale problems.
So when you take all this in, it forces you to step back and ask a really important question. What is the highest point of leverage you have in software development?
And the answer is right here. Think about it. A bad line of code, that's one bug. A bad part of your plan, that can spawn hundreds of bad lines of code. But a bad line of research, that can lead to thousands of lines of completely wasted effort. Your highest point of leverage is always upstream. It's not in the code. By absolutely nailing your research and your planning, you're not just dodging bad code, you're guaranteeing that the AI builds the right thing, the right way, the very first time.